Today, we've already talked about adding and subtracting complex numbers and i's, and today we're gonna be moving along to multiplying and dividing complex numbers. We talked a little bit about plotting complex numbers, and we're gonna talk about that one more time, but that's pretty easy, I think. Remember with complex numbers, is that this is standard form. This is how you should be writing your answers, where A is your real part, and the BI part is your imaginary part. So real first, then imaginary. So each of these examples you're going to write as a complex number in standard form. So on the first one, what am I going to do? We are going to distribute, exactly. So we're multiplying I through here. So I times 9 will be 9I. And then we have an I times a negative I, which is negative I squared. Once you do this, you need to simplify. So we know that I squared actually equals what? Negative 1. So that means I have 9I and I have minus a negative 1, which makes what? A positive 1. Okay, and then we have to write this in standard form. So how will I write this in standard form? Very good. 1 plus 9I is correct. So I would encourage you, when you are doing this, to write out each of your steps, because a lot of you are like, oh, I squared, it's negative 1, and you'll end up writing this as 9I minus 1, which is not correct. But if you write it as 9I minus the negative 1, then you see that the two negatives make a positive. Yeah? Two negatives side by side become a positive. If you want to think about it, it's really like, so if we have 9I minus, and it was negative 1, right? This is really a negative 1. And negative 1 times negative 1 is positive 1. Yes?
When you write your answer, do you have to put the 1 plus in front?
Yes, so your real part always needs to go in front and the I part in the back. So once you finally simplify, then you're going to write in that order. Okay? Any other questions right now? Okay. Example 4, which really should be different numbers, but that's okay. So 3 plus I times 5 minus I. What would be the easiest way to do this?
Box.
Yeah, probably use your box. You can use foil if you want to. I'm going to go ahead and make a box because I feel like it organizes everything for me a little bit better. So I'm going to make my box here, and along the top I'm going to write 3 and a positive I, and then we have 5 and a negative I. Make sure you have your signs, especially your negatives, so you don't mess up there. And then in our box, we're going to go ahead and multiply. So we have 5 times 3, which is 15. 5 times I is 5I. Then we go down here. Negative I times 3 is, and then negative I times I is negative I squared. Okay, but since I squared is negative 1, that means this will end up becoming a positive 1. Good. And I'm just going to show you right here. We'd have a negative times a negative 1, which makes a positive 1. Right? Because we have a negative I squared is negative 1. That will make 2 negatives, which is a positive 1. So I'm going to cross this out because it's just a positive 1. Okay, so my real part is a 1 and a 15, and when you add that together, what do we get? 16. And then my I part, we have a 5I and a negative 3I, which makes a positive 2I. And that's my answer. So I got the 16 because I had my 15 right here. And then remember, this part ended up changing to a 1, a positive 1. Other questions? Okay, next example. What is my issue on this example right here? Oops, sorry. We can't have what in the denominator? An I. So remember when we had our roots and you had like 3 minus root 2? How do we end up getting rid of that root in the denominator? Multiplied by the, kind of like that. It's called the conjugate. Okay, so what, you're going to have to do the same thing here. So what is going to be the conjugate on this? 1 minus I. And whatever we do to the bottom, we also have to do to the top. Okay, so when I do this, I would go ahead and make a box in the bottom to make sure that you don't mess up. Okay, so I'm going to make a box. And we have 1 minus I and 1 plus I. So when we multiply here, we have 1 times 1, which is 1. 1 times negative I is negative 1I, or just negative I, either way. Hold on, and then I plus 1 is I times 1 is I, sorry. And then I times negative I is negative I squared, which we know is actually going to end up changing to be what? Positive 1, because we'll have a negative 1, right? So I'm going to cross this out and end up putting a 1 here. So negative I squared is going to change to positive 1, which we just did that on the previous example, correct? Okay, the whole purpose is to get rid of the i's. Do these end up canceling out? Yes, we do not want an I to be in the bottom part of our answer here. And so now I'm just left with 1 here and 1 here, which makes 2. So my denominator is 2. Okay, and then what am I going to do with the top part?
Negative 5I.
Close. We're going to multiply the 5 through here. 5 times 1 is 5, and 5 times negative I is,
Negative 5I.
and is this in the correct order?
No, that's why I was going to change it.
Yes, it is in the correct order, because you have your real part and then your imaginary part. And if you go back to the beginning, standard form is you want your real part and then your imaginary part. Okay, and there's nothing here that can simplify or reduce, so that is my final answer.
You can't like think let's see out and do like that.
No, you shouldn't. You just want to leave it like this because you want your real part and your imaginary part. You could also write this like this, 5 over 2 minus 5I over 2. You could also see your answer written like this as 2 separate fractions. So either way, these are both correct.
Okay.
All right, next example. What am I going to do? We're going to have to multiply by the conjugate, which is 3 plus 2I. And whatever I do to the bottom, I also have to do to the top. So on the bottom, I'm going to multiply and make a box. What do you think I'm going to do at the top?
The same thing.
You're going to have to make a box as well. Exactly. So I'm going to give you guys a chance to try this one on your own. Okay?
Do you have the i's cancel out on the denominator?
That's what should always happen. The I should always cancel out in the denominator.
Oh, okay, I did it right.
They're not going to cancel out in the top though.
Yeah, I did it right. I thought I did it.
So when you get your answer, raise your hand and I'll come around and check.
do something.
Okay, I'm gonna go through it here in a second. Remember that I squared is negative 1. I have 11 here and 13 here. So wait, we're gonna work through it right now. Okay, the answer that I have is 11 plus 16i over 13. Okay, so we're gonna work through it. If you didn't get that answer,
I got the 16i right.
good. Watch to see maybe where you made an error. It could be with positives and negatives. Please do not have out any cell phones. Thank you. Okay, so I'm going to do the denominator first. So we have our 3 and negative 2i and 3 and a positive 2i. When I multiply here, 3 times 3 is 9. 3 times negative 2i is negative 6i. 3 times 2i is 6i, and then 2i times negative 2i is negative 4i squared. Okay, so we wanted the i's to cancel out here, which did. Negative 4i squared. Whenever you have I squared, you know that it's a negative 1. So this really means negative 4 times negative 1, because I squared is negative 1. And what is negative 4 times negative 1?
4.
A positive 4. So we have a 4 and a 9. And what is 4 plus 9? 13. So my denominator is 13. Okay, so now we're going to go do the numerator. So I'm going to make a box again to multiply. Okay, and I have 5 and a positive 2i and 3 and a positive 2i. So when I multiply here, 3 times 5 is 15. 3 times 2i is 6i. 2i times 5 is 10i. And then 2i times 2i is 4i squared. But we know that I squared is what? So we have 4 times negative 1, which makes negative 4. So here I have a negative 4 and a positive 15, which makes what? 11.
11 plus 16i.
Good. And then 10i and 6i makes my 16i.
I figured out where my mistake was.
Good. And I can't reduce. So that is my answer. Do we have questions on that? No? We're good? Okay. Yes, we're going to graph a little bit. Okay, so on this one, when you're plotting complex numbers, remember that your real part is basically your x-axis and your imaginary part is your y-axis. So you're gonna have like around 5 problems or something in your homework to plot. Just do them all on one graph, and you'll just label them A, B, C, D, E, or number 1, number 2, whatever problems they are. Okay. So if you have 3 and negative 2i, that means you're gonna go. Remember, to the right is positive, left is negative, up is positive, down is negative. So this part is a positive 3, so we go right 1, 2, 3, and then down 2 for our imaginary part. I make a point there and I label that A.
That's easy.
Yeah.
That's not biggie.
So B, we're going to go left 2, up 4. 1, 2, 3, 4. Make a point, and that is B. I'm going to give you about 30 seconds to try to graph those last 3, and then I'll plot them.
Oh. Is this one meaning negative? I mean, this one's y value?
What are you looking at? C, you mean?
Yeah. I mean D.
D, 5. It's just on the real part. You go right 5 and make a point. And your C is wrong because it should be on the line. Okay, so for C, it's just 3i, 3 in the imaginary. So you're going to go up 3, 1, 2, 3, and you're not going anywhere. So that is C. D is 5, so you go right 5, 1, 2, 3, 4, 5. And that is your D. And then E, we have negative 1, 2, 3, and then negative 3i down 3. And that is your E. questions on plotting? Okay. This part goes along with your worksheet tonight. In order to add fractions, they have to have what? Same denominators. On example 1 there, do those have the same denominators?
Yes.
So that means that what are we going to just do?
Just
Add the top. So what am I going to end up with?
7 over 1 over 4i.
Good. And is that answer okay?
Yes.
No. Why not?
It's not in descending order.
Because there's an I in the denominator, and we can't have i's or roots in the denominator. So what am I going to multiply in order to get rid of the I in the denominator? We're going to multiply by 1 minus 4i, which is the conjugate. Very good. To be safe, I recommend doing your FOIL method or the box. Okay? So I'm going to go ahead and do that. I'm going to make my box. And I have my 1 and my positive 4i and 1 and negative 4i. Again, be very careful with your signs. So in this first part here, 1 times 1 is 1. 1 times 4i is 4i. Negative 4i times 1 is negative 4i. And then negative 4i times 4i is what? Good. Negative 16i squared, which we know will make negative 16 times negative 1, which makes positive 16. So I have 16 plus 1, which means my denominator is 17, because my 4i and negative 4i canceled out. And the whole purpose was to get rid of the i's. So if you're multiplying and you end up with an I in the denominator, you obviously did something wrong, because you do not want any i's in the denominator. And next, what will I do? Good. 7 times 1 is 7, and 7 times negative 4i is negative 28i. And is that in descending order or in standard form, I mean? Yes. So there's your answer. Okay, questions there. All right, example 2. What you have to be careful about with subtracting is that this minus sign right here needs to go to everything on the top. You would need to distribute it. So if there were 2 terms up here, you would end up distributing the negative to both of the terms. In this case, there's just a 3, so I'm just going to make this 3a negative. And once you've done that, change this to an addition problem. Okay, so we need to distribute that negative to the top, and then it changes to an addition problem.
So negative I squared equals a 9?
Negative I squared would end up making a positive 1.
No I?
No, because I squared is negative 1. All right, so what happens here on the top? Very good. You have a positive 3 and a negative 3, which ends up canceling out. 3 minus 3. Okay, so if this is a subtraction, you have to distribute the subtraction to everything on the top, which makes that a negative, and then you change it to an addition. So now I'm left with, on top, 4i over 1 minus i. And is that answer okay?
No.
No. What do I need to do? We need to multiply by 1 plus I, which is the conjugate. Yes, 1 plus I. All right. So, and then what should I do at the bottom? Go ahead and make a box, right? Because you're multiplying 2 terms by 2 terms, and we want to make sure we don't mess up with like our I squareds and negatives, so it's best to see what's happening. So along the top here I have 1 and a negative I, and along the side I have 1 and a positive I. So we have 1 times 1, which is 1. 1 times negative I is negative I times 1 is I, and then I times negative I is negative I squared, and we know that negative I squared is going to end up becoming a positive 1, because that is negative 1, which is a positive 1. So I have a 1 here and I have a 1 here, which makes my denominator 2. And the i's canceled out. On the top, what am I going to do? Distribute. Very good. 4i times 1 is 4i. And 4i times I is 4i squared. But I squared is really what? So this right here is really 4 times negative 1, which is negative 4. So this goes away, and we really have a negative 4, correct? And then how do I write my answer? Negative 4 plus 4i over 2. Now, can 2 go into both of those terms? Yeah. And the only way to reduce is if it goes into both of these, right? I can't just reduce it with 1. So negative 4 divided by 2 reduces to negative 2. And then 4i divided by 2 reduces to 2i. And that's your answer. And if you want to make sure you do it correctly, write these as 2 fractions, how I talked about at the beginning. Write it as negative 4 over 2 plus 4i over 2, like first split it, and then reduce it. Okay, do we have any questions on this? Okay, patterns with I. I'm going to show you guys a couple ways of doing this, but before I do this, let's just start making a list, okay? So if we have I to the first power, what does that equal?
1.
I. Okay. If I have I to the second power, what does that equal? Negative 1. If I have I to the third power, does anyone know what that's going to be?
I to the negative second.
It's going to end up being negative I, and I'm going to show you why. Because we know that
That rhymed.
we know that we know that I squared is what? Negative 1, and all you're doing is taking that negative 1 and multiplying it by another I, which would make negative I. Okay, I to the fourth power, what's that going to make? A positive 1, because we know that I squared is negative 1, right? And if you have 2 I squareds, that means you have 2 negative 1s, which will end up making a positive 1 when you multiply them together. Okay, I to the fifth power will end up making, we're just multiplying another I to this, right? It's going to be I. Good. I to the sixth power is going to equal, because now we're just taking another I and multiplying it to this, right? And you'd end up with I squared, which is negative 1. What do you think I to the seventh is going to be?
Hey, that's not fair.
Negative I. What do you think I to the eighth is going to be? One is correct. I know it's kind of hard to see with how I have this written, but do you guys see a pattern? So every 4, it makes a pattern. Okay? So this is one way to see the patterns. Okay? Another way to do it is that I always know, I remember, it's easy for me to remember that I squared is negative 1. That's easy for me. So if I can put everything in terms of I squared, you can figure it out mathematically. And what I mean by that is, well, first of all, in order to put something to like a square, it has to be even, right? So on this example 3, I would write this as I times I to the sixth, because 6 I can end up dividing by 2. Do you guys understand what I'm saying?
But it's a negative.
Okay. So what I'm going to do is I'm going to have I times, and I'd write this as I squared to what power? The 3, because 2 times 3 makes 6, okay? And then I have I times, and we get negative 1 to the, negative 1 to the what? Third. And negative 1 to the third power, will that make a negative or a positive? So then I have I times negative 1, which ends up making negative I.
Let's see.
I'm just writing, and then I always move my hand. Please be patient.
I'm recording by the way.
I know, and so are you.
I know that.
Okay. So this is like a little bit of work, but for me, that's easier to remember than this pattern. For some people, this pattern is easier to remember than this.
Definitely.
Okay. So if I were to do I to the 8th power, now granted we already know the answer is 1, okay, because of the pattern we showed there. But if I were to write this as I squared, it'd be I squared to what power?
The fourth.
The 4th power. Okay? And then I squared is what? And negative 1 to the 4th power, is that going to make a negative 1 or a positive 1? Positive 1, so my answer is just 1.
Not high.
Wait, but it's a negative 8.
If it was positive, then you'll do it with the I.
So, what do you notice though with I's? If you have an odd power, your answer is going to end up being a I or negative I. And if you have an even power, your answer is going to be 1 or negative 1. Okay, do you guys want to try 5 on your own? Is your answer going to be in the 1? Is it going to be 1 or negative 1 or I or negative I? I or negative I. Good. So right there you could eliminate some answers, right, if it was a multiple choice question. Okay, so I'm just going to write this. This is how I do it. I'd have I, and then you have, it's going to be I to which power? The 80th, because 80 plus 1 makes 81, right? And then we want to write it as an I squared. So I have I squared is going to be to what exponent? 2 to the what power will make 40? Or 2 to the what power will make 80? That would be 40, right? Because powers to powers you multiply. 2 times 40 is 80. So then you'd have I, and then we have negative 1 to the 40th power. Is negative 1 to the 40th power going to give you a positive or a negative? Positive. Even numbers will end up giving you a positive because you're pairing up 2 negatives make a positive, right? So if you have an odd number here, it'll be negative. If you have an even number here, it'll be a positive. And then you have I times 1, which ends up being I as your answer. Because since this was an 81st power, I have like an odd number. And so in order to make it that I can put it 2 squared, because I know I squared is negative 1, I have to take 1 I away. So that's how we know that all odd exponents will either give me an I or a negative I. Do you guys have any other questions there right now? Does this make sense, the process that I'm doing here? No, it doesn't? Okay, well, let's try one more example then. No. Let's just do one more. I to the 70th power, or exponent.
I think that's going to be 1.
You're right. It's going to be 1 or negative 1 because it's an even exponent.
Is it 1? You can do that in the calculator?
Oh, I'm just doing something.
Oh, okay. I was like, wow, it's amazing.
Okay, so it's going to be I squared to what exponent? To the 35th.
Oh, so it's negative 1. Negative.
Because 2 times 35 makes 70. So then you'd have negative 1 to the 35th power, and you'd end up with a negative 1. Yes.
I'm just confused, like, how do you go from square to this negative one?
Do you understand how I got I squared to the 35th?
Isn't it kinda like?
Because powers to powers you multiply. 2 times 35 is 70. Okay? We know that I squared represents negative 1.
She just wants to get to the isolated so you put negative one and everybody. So 35 keeps goes away?
Well, it's not, because think about it. If you multiply 1 times 1, it's still 1, right?
Oh, okay.
So we're just multiplying a whole bunch of ones together. So I know that if I have 35 negative ones, they're going to all pair up, but then there's going to be one negative 1 left over that doesn't have a pair. And so that's why I'm going to end up with a negative 1. Okay, real quick, I just want to show you back to these patterns. Because remember how we had a pattern here? How it goes if you remember I, negative 1, negative I, 1, you can remember this pattern, okay? Well, what happens with this pattern is that if you took, for instance, I'm going to show you, you can divide, 4 goes into 70, okay? How many times does 4 go into 70?
20,
20 times?
15, like 80.
Well, you start, 4 goes into 7, how many times?
What?
1, that's 4. Subtract, 3 left over, bring down the 0. 4 goes into 30, how many times?
5.
Or 7. And that's 28. And there's 2 left over. So what happens is you're going to end up with I to the second power, which equals negative 1.
Look at yourself.
So if you did the 81, so I'm showing you the pattern way right now, okay? So if you take and we go 4 divides into 81, how many 4s are an 8? 2, subtract, 0 left over, bring down the 1. Wait, what am I doing wrong? That's, okay. It goes in 0 times, right? 4 times 0 is 0, 1 left over. Okay, there's 1 left over, so I to the first ends up becoming just I. Okay? So basically you're going to take whatever your exponent and divide it by 4, but then you have to remember all 4 of those. But you could write them down and remember them. Yes? Yes. Because there's 4 answers. 4 different answers.
Now for the, like, the extra example, like we did 3, would that be the same thing or something?
Yeah.
Yeah, it would.
Okay, any other questions?